Assalamualaikum and good day to everyone. I'm Fitri Yaakob from MJIIT UTM KL. So topic smart water conservation for Mosque through IoT with a tagline save water, save energy and save the world. So what is the issues, what is the challenges for this project? So reduction in water supplies is a huge concern in the world. There is a significant drop of amount of water supply nowadays by comparing it to the last 5 years. Malaysia, is a Muslim country, so the frequency of people visiting mosque in a day is very high. Huge amount of clean water has been wasted for its daily activities that do not necessarily need clean water. For example, we are using the clean water for flushing toilet, and also we are using the clean water for the watering plants. Massive usage of clean water supply from local water agency resulting high water bill costs. Secondly, increase the operation cost of a mosque. So these 2 points is a critical point for a mosque or masjid in Malaysia context. Water tanks will be on the top of the mosque. Yes, this is very common, specifically on the roof. It's very troublesome for the committee, for the masjid committee to monitor the water tank if there is any problem. So this is the current issues. And so what actually the problem that we want to solve? So we want to reduce the water usage from the local water agency, such as from Shabas, as well as the high water bill faced by the mosque. If we can save the water, then we can save the energy. We can reduce the bill for the mosque. Second, to monitor and control the water flow by using IoT platform. So we come out this solution to improve, to give the awareness to the community that please use water efficiently. So we have our main tank, we have our main supply tanks. Currently, Selangor, we have a Shabas, and then we propose rain harvesting. We link together with the IoT. So at least we know the clean water is used for wudu, but for flushing toilets and for watering plants is enough to use rain as a source. This is our solution and our novelty. On the left side, figures shows that this is our prototype. So we have our main water tank. Let's consider the white one is our main water tank. So we receive the water from the Shabas. So the Shabas on the right top, on the right top, that for the Shabas water tank. So we have another on the left side is for water catchment area. So this one, the source from the raining. So this is rainwater tank. So means that we will use the rainwater first for the because we use rainwater, and then we have a filter, UV filter, to filter the unnecessary things in the rainwater tank. So at least we can use this rainwater tank for our daily usage in mosque. If the tank is empty, then we will use Shabas water tank. So on the right hand side here, we have a block diagram of our smart water flow system. We have our controller, we have our relay as our actuator, valve as our input, we have a power supply, water sensor flow, ultrasonic sensor, and Wi-Fi. Wi-Fi is our important component here, since we are connected everything for this water level conditions through the Internet of Things. So this is example. We have collected the result based on our pilot study in one of the masjid in Kuala Lumpur, Setiawangsa. We call it Masjid Mutakin. So we have this result for the percentage of water level in main water tank. So this is indicate the level of the water. So means that the committee can easily determine the condition of that tank. So we know the amount of water flow, not only the level, the flow also we can monitor. And then the percentage of water level in rainwater tank. So we have a two water tank just now, the main water tank and the rainwater tank. We cannot monitor from the Shabas, but the Shabas is our sources. So basically, most of the masjid, they will store the Shabas water in the main water tank. And we have extra rainwater from the raining. Then we can monitor both, and we have our valve manual control button. And this valve is to control on and off for these two tank. So this is the flow chart. Now the sensor 1 and sensor 2. So sensor 1 for the main tank, sensor 2 for the rain water tank to detect the level, and then we take the data, we compare it, and then we'll determine either valve on or off or water flow on or off. And then everything is through the apps. So this is in terms of practicability. Yes, easy and faster installation to process. It required a few modification and additional part to install. The most important here is required for Wi-Fi server in Mosque, and then current water supply will not disturb in long time. So very suitable for any housing area to reduce water bill. So this is our through our apps monitoring system. This is a real data measurement. So means that the committee of the masjid can easily knows the current scenario or condition for their water level of their tank. So this is the result percentage of the water level of rainwater tank increase. You can see if zero, what happened. So this is indicate that our rainwater tank is now zero. So we will use Shabas water because this is depend on the rainy season. If they have a lot use of rain, they will have a lot of extra water in the rainwater tank. And this valve is manually closed. So valve manually open so we can check through the water tank from the water Shabas. This is our pilot study at Masjid Muttaqin Wangsa Melawati. So we have installed our sensor there, and for the product comparison, compare so far the available in market is only smart meter TNB, but compared to our product, we have more advantages due to the apps and remotely can be turned on and off, and also for the use rainwater as alternative. What is the impact? Yeah, they have a four impact here: economic, environmental, safety, and commercial value. So we can reduce water bill, free to download our apps. We can utilize rainwater as the main water source instead of Shabas, and then increase awareness on water consumption. So monitor the water flow via Blink apps, reduce the occupational safety hazard, and this is low cost promotes. Before I ended my presentation, let's take a look on our project development. By that, thank you very much.